Hello all. So in all our previous session, we have gone through with the basics of Arima as well as we have learned this MA and this AR as well. We know here this AR will return my some value of P and this MA, which is my moving average model, will return some value of Q. And how exactly we can compute our value of P and Q using our PACF plot and this ACF plot, and both the plot works on the concept of correlation. That's what we all have learned in all our previous sessions. So in this session, we are going to learn what is this I and what is the idea behind this I, which is my integrating, and the concept is exactly differencing. So what is differencing? So before understanding differencing, let me give you a quick overview of what is stationarity in time series data. So whenever your variable is constant with respect to time, that is exactly my stationarity in data. Let's say on y-axis I have some price of any mod, or I can say price of any product, and on x-axis I have some time data. Let's say this price is, let's say, this one. So you will observe over here it is almost like a straight line. So that type of trend is exactly my stationarity trend, or you will see there is no trend available over here. So that type of trend is exactly known as stationarity. So it means the main goal of differencing is that whatever data you have to make that data stationary. That's the main goal of differencing concept in Arima model. Assume it, you have some data over here. So let me note down as, let's say you have some data as 100, 110, 120, let's say 105, and let's say 109. So here you will observe you don't have a stationarity data. So whenever you are trying to apply your concept of differencing over here, so assume it, I am going to apply a first order of differencing over here. So assume my D equals to 1, which says, yeah, my data follows right now first order of differencing. So it means whatever operation I am going to perform on this entire data, that operation is nothing but my shifting operation. So whenever I have to apply differencing on my data, I have to apply shifting over there. So let's say I am going to apply my shifting of 1. It means differencing of 1 order. So these all data gets shifted over here. So this will exactly give me 110 over here, not this 110. This will become 100. This will become 110, and this will get shifted over here. This will get shifted over here, and this will get shifted over here. So if I am going to do a first level of subtraction over here, then you will analyze over here. It will exactly give me 10. It will also give me 10, and it will give me minus 15, and it will give me 4, or I can say plus 4. And once I will apply my first level of subtraction, let me write down over here, first level of subtraction. So you will see over here, whenever I will perform first level of subtraction in my data, then we will try to see whether there is some trend in this difference or not, or I can say whether difference is either continuous increasing or continuous decreasing. So if you will notice over here, your difference is still follows some kind of trend. So whenever your difference is still follows some kind of trend, in such case you can again apply a concept of differencing on your data. And once you will again apply differencing on your data, that is your second order of differencing, which is my D equals to 2. So in real world problems, either you have D equals to 1 or you have D equals to 2. In a very rare case, D equals to 3 or D equals to 4. That's a very rare case. I have hardly found this case whenever I have D equals to 4. So after applying first level of subtraction in your data, you will observe still I have some trend in my data. It means I have to make this data stationary. It means we are just trying to remove trend from this data. So let's apply a second level of differencing over there. So how I can apply over there? Let's say I'm going to name it as S1. So what exactly will be my S2 over here? So let me remove all this stuff over here. So when I'm going to apply my second order of differencing over here, which is my shifting of 2, so in such case 100 will get shift to here, 110 will be here, 120 will be here, and this 105 will be over here. So what will be my output at second level subtraction? So that is nothing but this 120 minus 100. So this 120 minus 100, that will give me somewhere 20. Similarly, this will give me somewhere close to minus 5, and this will give me somewhere close to minus 11. So now you will observe over here, you don't have any trend in your data. It means your D value for the data, for this one entire data, your D value is exactly 2, that we have to pass to our ARIMA model to do several kind of prediction with respect to date and time. So now we can set our D value as 2, and whatever P value has obtained using PACF, and whatever Q value we have obtained using ACF. Now our P, D, Q pair has ready, and what we have to do, we have to just pass this pair to our ARIMA model. And once I will pass this pair to my ARIMA model, we have to just fit my data to my ARIMA model, and internally it will learn all the relationships, and then it will do some kind of predictions on my data depending upon what use case we have. But in AutoML, or I can say but in Auto-Arima, we don't have to pass this PDQ pair, because Auto-Arima, it is just a AutoML model. It will already consider all the possible pairs of PDQ in a automated way. But we have to understand how it is actually considering all the pairs. What was the maths behind it? What was the logic behind it? And this is exactly all the logic behind that. So that's all about this session. Hope so you will love this session. Thank you. Have a nice day. Keep learning, keep growing, keep motivating.